In last class, I think so we completed till question number, I said to do that question number 34 and 35. Let us start reduction formula. Yeah, sine power 4 and cos power 4 dx. So yesterday class I explained about sine power even, cos power even, sine power odd, cos power odd. Like for example, 0 to pi by 2 is there. What is sine power nx dx? This is equal to n minus 1. Here n minus 2, n minus 3. So like that, if the power is even, we are going to get 1 by 2 into pi by 2. In case same value, if n is even, when n is even, we'll get pi by 2 is last. In case the sine power n x dx, if n is odd, same n minus same procedure, n minus 2, n minus 3, so on. Here 2 by 3 will get finally 2 by 3 when n is odd. Okay, till we'll get 2 by 3. So not only sine power n, it may be cos power n is same formulas like replace sine by cos also will get the same answer. If the power is even, you'll get pi by 2. If power is odd, you'll get 2 by 3 at last. Okay, if both will be there, like look at here, you get 0 to pi by 2. In case if you are getting like sine power mx into cos power nx dx. Simple student, what is the sum of the powers here? M plus n. Here I am starting with m minus 1. M is there, m minus 1. See here, power is n, numerator is n minus 1. Here next to m plus n minus 2, m minus 3. So on. After completion of m, you can start with n. We can start with n. So coming to the question, already they have given one question, 0 to pi by 4, 0 to pi by 4, sorry here, it is the limit is pi by 4.
Sir, if m is equal to 1 or 3, sir, then the whole thing will become 0, no, sir?
No, not like that. You should not, if it is 1, for example, sine power 1x, 1x why? 1 is becomes minus cos x, Got it? If power is 1, we can do directly. Power is 2, power is 2, we can apply the first property 0 to f of x dx already be done, that is NCERT question. If more than 2, if the power is more than 2, you can go through that.
Okay, sir.
Here n is greater than 3, I mean greater than or equal to 3. Okay, if power will be 1, will we get direct standard. For power is 2 also we have a property. If the power is more than like 2, that is 3, maybe 10, maybe 15, like that, this kind of problems we can. So here cos power 4x dx is there. I'm going to apply this property. So look at here, and the property is 4 plus 4, first 8, first I want to finish it. So 4 minus 1, 3, 1 by 6, 1 by 6. Okay, fine. Next, this 4 completed. Next, coming to this 4, nothing but 3 by 4, 1 by 2, then pi by 2. When you get 1 by 2, when you 1 by 2 is repeated, 1 by 2 you'll get, then you immediately can write pi by 2. Got it? Now this is the answer. Okay, 3 ones are 3 twos are. And what is the answer? Numerator, we cannot cancel this 3. Numerator is 3 pi. What is the denominator? 16, 64, 1. What is the answer, students, here?
256.
256. Huh? Is there any option 256? No. The answer we should get.
Sir, here the limits is pi by 4.
Oh, Right. See here, limits we can convert it into pi by 2. Sorry, pi by 2. So how to write pi by 2? Pi by 4 is given. When pi by 4 is given, we can write, yes, see, 1 by 2 into 2, 0 to pi by 4. Yes, sine power 4, cos power 4 dx. See students, how to convert it into pi by 2? The limits are pi by 2. How to convert to pi by 2? See, already we have seen if integral 0 to 2a f of x dx we have written 2 times of 0 to a f of x dx. Here it is when f of 2a minus x is equal to f of x. So when you consider this as f of x, when you find the f of 2a, 2a. So but see whenever the function is even, that is nothing but function is even, is your sine power 4 cos power 4 is even or not? I want
Yes,
to
sir.
apply reverse. I want to apply reverse. This 2 is the 2 I want to multiply here. We can. So this, can I multiply this 2 here? I have written 1 by 2 into 2. So I want to change pi by 4 in terms of pi by 2. So now this is equal to, when I multiply here, like this is equal to, yeah, it can be written as 1 by 2 times of integral 0 to pi by 2 will get. Pi by 2 sine power 4 cos power 4. Now we can apply the property here. So 1 by 2 is there. Outside is 1 by 2 is there. So everything is same. But here whole value into outside 1 by 2 is there. Now what about the value? 3 pi by 5 1. Right. When the limits is 0 to pi by 2 alone, we can apply these properties. Not pi by 4. Pi by 2
Sir,
only.
I have one doubt, sir.
Yeah, you can.
Sir, instead of 4 and the powers of 5, instead of 5 by 2, 2 by 3 should come, sir.
Yeah, whenever 2 by 3 will come. That time 2
Okay,
by
sir.
3 will come. Okay. Sure, see here. When starting value is even, till end also will get even only. Whenever it is 9, if it is 9, for example, take 5, here 4. 5, 4 becomes 9, 9, 7, 5, 3, like that. Some of the value is even, then at last we'll get 1 by 2. Some of the value is odd, we'll get 2 by 3. Okay, answer is 3 pi by 512.
Sir,
Yeah,
in all the three formulas that you given, sir, finally we added pi by 2, sir. Multiply with pi by 2, sir.
all the three formulas.
Formulas that you given, sir. Finally,
Okay.
multiply by pi by 2, sir.
When you get end of the value is 1 by 2, multiply with pi by 2. Otherwise, don't.
Like if you get the 2 by 3 second one, sir.
2 by 3?
The second formula, sir. That's it, sir. 2
Okay.
by 3, we can just leave it, sir.
Yeah, just leave it. Just we never get pi by 2 here.
Okay, sir.
When you get 1 by 2, then only multiply with pi by 2. Whenever you get 2 by 3, just leave it. Till 2 by 3 alone you can find.
Okay, sir.
Okay. Yeah, so this is the answer is first one. Coming to the second one. Second one, see here, we are always the given in reduction formula, whenever sine power n is there, this can be represented with in. What is the power here? In. N value is 5, I 5. N value is 6, we'll write I 6. So what about here? We'll write I m comma n. Powers are different here. M here n. It can be denoted by I m comma n. Okay. So what it will be denoted? I n. Okay. Fine. So here in the question, the power is n so that it can be represented with in. When we expand, LHS is same, IN alone, IN, here also IN. When we expand this RHS, we are going to get in this form, then for what value of A comma B, it will be in the form of A plus B into IN. So it's simple question actually, and logical question. Take that given formula, IN. in is equal to integral 1 to e log x whole to the power of n into dx. Okay, fine. Now I am going to apply UV rule here. How can you evaluate this with help of UV rule? So whenever they give a single function, you can multiply, you can take as 1. 1 is always algebraic function with help of I later. What it will be first? Logarithmic first. So this is u, this is v. So integral uv formula is u integral v minus integral u dash integral v. Fine, students. So now I n is equal to u log x whole to the power of n integral 1 into dx 1 to e minus integral u dash. U dash means log x whole to the power of n derivative into integral 1 into dx whole bracket into dx. Just to UV rule. So here this is clearly log x whole to the power of n into integral 1 is x from O for all 1 to e. See here, I already told you don't apply the limit for only this x. Entire function you have to take the limits. Minus here the derivative of this n log x whole power n is n into log x whole to the power of n minus 1. Again log x is 1 by x. Here integral 1 is becomes x, okay, into dx. Got it? Integral 1 is x. Log x derivative 1 by x, x get cancelled. Okay, so in is equal to, like when I apply the upper limit here, log e whole power n into e minus log 1 whole power n into 1. I applied upper limit, lower limit for first one. Coming to the second one, n is common, take it outside, integral log x whole to the power of n minus 1 into dx. Okay, 1 to e. See student, with help of the equation 1, given equation. So equation 1 means this is equation 1. What is equation 1? So if the power is n, we have taking as in. Okay, here if the power is n minus 1, what should we write here? What should we write? I n minus 1. Okay, what is log e value here? Log e 1. Log e value is always 1. 1 to the power of n, 1. 1 into e. Log 1, what is the log 1 value? 0. 0 to the power of n, 0. So finally here e minus n into in minus 1. We will write like this. E minus n, this can be written as in minus 1 because power is n minus 1, you can write n minus 1. So when we compare this with a plus b into in minus 1, what is a comma b? A is equal to e, b is equal to minus n. See here, a is equal to e, b is equal to minus n. Got it? Simple question. Logical question. Apply UV rule, that's all. Okay, sir, this is also a logical question. Any doubts? UV rule I applied the limits directly we got in the form of a plus b into in minus 1. Coming to the next question, your 38. Your 38 is simple, if possible you can find in. In is equal to integral 0 to pi by 4 tan to the power of nx dx. Power is in. Then here limit n tends to infinity. Limit n tends to infinity. N into in plus 2 value. Okay, student, fine. Here in. What is in plus 2? First, I want to evaluate this value. In plus 2. This is equal to 0 to pi by 4 tan power n dx plus integral 0 to pi by 4 tan power n plus 2 into dx. So 0 to pi by 4 is common. Here tan power n plus 2. So tan power n I want to take common. Then 1 plus tan square into dx. Got it? I'm taking integral common. Dx is common. Tan power n is also common. Tan power n plus 2 can be written tan power n tan square. This can be written as tan power n I'm taking common. So this is 0 to pi by 4 c students. Here tan power n into secant square. 1 plus tan square is secant square x dx. I already told you one of the formula is, what is the formula? I told you that like in last class I have given f power n into f dash dx is equal to f power n plus 1 by n plus 1. Got it? Function, its derivative is here. It can be written as like this. So this is becomes what? Tan power n, tan x derivative secant square. So it can be written as tan power n plus 1 by n plus 1. Yeah, but the given question is what? Limit n tends to infinity n into
Sir, could you explain the last before step, sir?
this one,
Sir, above that, sir. That one, sir.
this one.
Yes, sir.
Yeah, here tan x whole power n. Okay. What is the tan x derivative? Secant square or not? So what is the function here? F value tan x. What is f dash of x? Secant square x. So it satisfies this condition or not?
Yes, sir.
So tan power n plus 1 by n plus 1. But from where to where limits? 0 to pi by 4. Fine. Tan power n plus 1 x. Now apply the upper limit. When you apply the upper limit, what will happen? Tan power n plus 1 pi by 4 minus tan power n plus 1 0 by n plus 1 is common. N plus 1 is a constant. Okay, what is tan pi by 4? 1. 1 to the power of n plus 1, 1. Tan 0 is 0, second one 0. So finally, I n plus 2 value is, so right side also apply the limit n tends to infinity. Yeah, n into, so right side value is 1 by n plus 1. Got it? Remaining tan pi by 4 is 1, 1 by n plus 1 only remaining value. Okay, but n tends to infinity. When you substitute infinity in place of n, infinity by infinity will get. But this is not correct to show that limit n tends to infinity n by, take n common denominator 1 plus 1 by n. So n get cancelled. Now replace n by infinity. So 1 by 1 plus 1 by infinity, that is equal to 1. 1 is the answer. Got it? I found in plus 2 value. We got tan power n plus 1 by n plus 1. From 0 to pi by 4, we simplify 1 by n plus 1 we got. I applied limit on both sides. We should not apply directly because infinity by infinity. So take n common denominator, cancelled and substitute, we'll get the answer. Simple question.
Scroll up a little bit, sir.
Yeah.
A little bit more, sir. Thank you, sir.
Yeah.
Can you show from the starting of the question, sir?
Sorry? This one?
Sir, no, sir. The 38th question, can you show from starting, sir?
Can I explain or else just scrolling down?
Can you scroll down a bit, sir? Down, sir. Thank you, sir.
Yeah. Yeah, okay. This is 2012. They asked here. Okay. I'm going to check this. See here, g of pi is there. G of pi, g of x. G of x already given. I want to find g of pi. C student g of pi. G of x is 0 to x. What is g of pi? 0 to pi. Cos 4t to dt. What is cos 4t? Sin 4t by 4. From where to where? 0 to pi. Now apply the upper limit. What is the upper limit? Sin 4 pi. 4 pi 0 minus sin 0 0. Sin n pi value always 0, no? Sin n pi value always 0. So sin 4 pi also 0. So anyhow g of pi value is 0. So this g of x plus g of pi, g of x plus g of pi value is 0. When you take g of pi is 0, okay, we'll get g of x, but when you take 0 here, something by 0 not fine, something by 0 not exist, 0 by something, the total value becomes 0, not possible. Okay, g of x into 0 0, not correct. So the option is, second option is correct. Second option will be correct. Even though if you want, you can take like g of x plus pi, you can take 0 to x plus pi. There is a property, like integral 0 to a plus b f of x dx can be written as 0 to a f of x dx plus 0 to b f of x dx. We can write like this. So not only this integral a plus b to c plus d f of x dx, it can be written as a to c f of x dx plus b to d f of x dx. These are the properties are there. With help of this property, I want to write like 0 to x plus 0 to pi. 0 to pi, just now I found that g of pi, 0 to pi value is what? 0. This is 0. So finally we are going to get g of x alone. It's a logical question, right? A simple question. 0 to x plus pi can be written as 0 to x plus 0 to pi. 0 to x already g of x. This is g of pi. G of pi value already 0. This is only correct. Okay. Substitute 0, we don't get g of x. Substitute 0, we don't get g of x. Substitute 0, we don't get g of x. So coming to this Leibniz rule. What is the Leibniz rule? First of all, you want to know the Leibniz rule. For example, f of x is equal to integral some pi of x to psi of x into h of x is there, dx is there. So when I want to find the f dash of x, when I want to differentiate here, then integral take here d by dx. F dash of x means d by dx of this value. So in that case, first replace x by upper limit. Already we have done into chi dash of x minus h of lower limit pi of x into pi dash of x. This is called Leibniz rule. This is called a Leibniz rule. So here a limit x tends to infinity 0 to x tan inverse x t square by this. So what I want to do, I want to differentiate this. This is f of x I want to take. I want to differentiate. When I want to differentiate, look at here. What is the question they have given? Limit n tends to infinity.
Excuse me, sir.
Yeah.
Sir, can you explain the rule once more, sir?
Which one? Okay. Leibniz rule.
Yes, sir.
Yeah. Once again. You can take any function. Okay, f of x alone you can take. Limits you can take any like now I have given pi, lower limit pi of x, upper limit psi of x into h of x. Sorry, not h of x, h of t you can take other than this variable into dt. So I want to find d by dx of f of x. Right side also d by dx of integral same pi of x to psi of x into h of t dt. See, actually, I told you very clearly, derivative integral always get cancelled. So left side is derivative of f of x, simply I have written f dash of x. Right side, whenever you cancel here, this here limits are in x variable, but the integrand in t variable. Now we have to substitute in place of t directly upper limit. So h of upper limit is psi of x into derivative, d nothing but derivative of psi of x. Nothing but, shall I write psi dash of x directly? Yes, we can write. D of psi of x I have written derivative, psi dash of x. Minus same way, replace t by lower limit and its derivative. That's all. This is called the Leibniz rule. Got it?
Yes, sir.
Yeah. See, limit, the question is limit extends to infinity. Integral 0 to x. Yeah, limits are in x variable. The function is t variable here. Tan inverse t whole square into dt by x square plus 1. See, I want to differentiate with respect to x here because tan inverse t in terms of t, but the variables are different, x variable. So I want to differentiate. Let us take this is like f of x. Now differentiating on both sides. Right side is clearly f dash of x, but left side limit extends to infinity. Yeah, here what I told you, just replace in place of t upper limit. Upper limits, so that x into that x dash minus lower limit is what? 0. So derivative of 0 always 0. If lower limit is 0, you can write directly 0 by, when I want to differentiate with respect to x, okay, above numerator is okay, but denominator already in x variable, already it is in x variable. So what shall we do here? The derivative of this is root x is 1 by 2 root x, x square plus 1 into 2x, 2 to get cancelled. Okay, 2 to get cancelled. Fine. Now from where to where? Limits are where to where? From limits are, yeah, limit extends to infinity, x tends to infinity. Okay, now I need to replace x tends to infinity. Okay, in place of x, I want to replace. So anyhow, I'm going to write one more step here. You can easily understand tan inverse. Okay, sorry here. Whole square. I forgot to write. This is whole square is there. As it is, you have to write. A tan inverse x the whole square. What is x dash value, amma? Derivative of x 1 by. Okay, here 2 to get cancelled. X is there. What I want to do is, in square root of x square plus 1, I want to take x outside. Shall I write 1 plus 1 by x square? I want to take x square completely outside. We'll write like this. Got it or any doubt? Any doubt, friends? I'm taking this x square is outside. This x I have written here. When I take x square outside, x square root get cancelled. Now we can replace x by infinity. So tan inverse infinity the whole square by 1 by square root of 1 plus 1 by infinity square. So what is tan inverse infinity value, anyone? Pi by 2 whole square by 1 by square root of, what is something by infinity? 0.
0.
Nothing. So pi square by 4 is the answer.
Sir, what happened to that x dash here?
X dash, derivative of x is what? 1. Got it? X dash nothing but what? D by dx of x, derivative of x. 1. Okay?
Okay.
X dash is 1. Clear? So Okay, this kind of question is important for JEE mains as well as advanced level.
Sir,
Yeah.
sir, if integral was like for both numerator and denominator was also in terms of t, sir, then we have to apply UB rule, sir. UBV rule, sir.
Numerator.
Sir, if denominator also has the same limit, sir, and denominator is also in terms of t, sir,
Okay.
then while differentiating, we have to take numerator and denominator as a single term and differentiate the UBV, sir.
That at the time you can why we want to differentiate that only we need no need to differentiate here. For example, as you asked that no need to differentiate. Your question is 0 to x. Your tan inverse x the whole square by a root over a tan inverse t the whole square by 1 plus t square is there. This kind of questions. Instead of x square, t square plus 1. So here nothing to do, just tan inverse x, just replace upper limit in place of t. In place of t. Tan inverse t whole square by root over 1 plus x square, that's all. Into x derivative. This upper limit alone you can differentiate, don't differentiate any other term.
Okay, sir.
Just limits alone you can differentiate. For example, why I have written 0? What is the derivative of 0? 0. 0 into anything is 0.
Okay, sir. Okay.
Okay. So only differentiate limits alone, not any other function. You can differentiate the upper limit, you can differentiate the lower limit. You can try to do this question, students. It's very easy. Again, limit extends to 0, 0 to x. This question you can try to do it. Okay, by differentiate numerator denominator separately. Like apply the Leibniz rule for numerator denominator separately, right? That you can try easy question. Otherwise, I can explain it. Yeah, question number 42. 42 is, see here, miscellaneous problems here, like G, here, what is the lower limit here? Whether 0 or E?
E, sir.
Yes?
Yes, sir.
E, okay. See, again, Leibniz rule we can apply. Again, Leibniz rule, because the function in terms of t, but the limits are in terms of x. So here, and also they are asking f of pi by 6. Do you know what is the function here? Integral of f of t is given, but we required only f of x. So now I am going to apply the Leibniz rule here. First to write the question. What is the question? Integral 0 to e to x t into f of t into dt is clearly equal to right side is sin x minus x cos x minus x square by 2. Now I want to differentiate with respect to x, d by dx of this value. When I differentiate here, I told you it cancel, but replace t by upper limit, replace t by lower limit. Okay. So, right, see here, x, f of x, what is the x dash? Lower upper limit derivative minus e, f of e into e dash. Okay, I apply Leibniz rule in LHS. Right side, derivative of sin x is cos x. Here, UV rule. This is u, this is v. Bracket x into minus sin x plus cos x. Yeah, minus x square by 2 is 2x by 2. Got it, students? Right, now left side is x, f of x, okay. X derivative is what? 1 minus. What is the derivative of EM? E is a constant. Constant derivative? 0? Yes or no? So cos x plus x sin x minus cos x minus x. See, minus into plus cos x minus cos x get cancelled. Okay, so remaining value is what? X sin x minus x. So x into f of x is the left side, take x common right side, sin x minus 1, x get cancelled. So finally you got the function is sin x minus 1. Now whatever the value they are asking, just we can substitute f of pi by 6, function of 30. What is sin pi by 6? Minus 1. Sin 30 is 1 by 2 minus 1 is minus 1 by 2. Got it? Yeah. Once again, see, I apply Leibniz rule left side, I differentiated right side. When I differentiate right side, we get finally x sin x minus x. Take x common. Left side x f of x get cancelled. Then x is equal to pi by 6. You'll get minus 1 by 2. Simple question. See, what is the reason that the subject becomes very difficult to most of the students? Because, see, how many are attending the class? Many of them, they are not attending. How was the questions? Very tricky and very, very easy. But those are absent, the student to understand their self, it is very difficult. Their own way, it may be sometimes it very difficult to understand. Leibniz rule is there. Limited tends to, that question is there. So that is the reason most of the students, they are not get that JE rank. Okay. Without hard work, without patience, the person cannot do anything. This easy problems, they can make them like a very difficult without attending the classes. Okay, okay, fine. Coming to 43. The 43 also they are asking dy by dx. Dy by dx means what shall we do here? Differentiate with respect to x, LHS and RHS. RHS is 0. So what is the question when I differentiate here? Again Leibniz rule. See, the function in terms of t, but limits are x variable. The function in terms of t, limits are y variable. Leibniz rule. Leibniz rule, right? Okay, fine. I'm going to do here itself. Yeah. Otherwise, I'll do. Question. What is the question, students? Integral.
The root
Pi
3 minus sine square t dt
3 minus sine square t into dt
plus
x.
y to 0, sir. Uh, cos t dt is equal to 0.
Now I want to
dy by
differentiate with,
dx is equal to.
yeah, d by dx. Here also d by dx. Right side also d by dx. Differentiate with respect to x. Okay, fine. These two cancel. These two also cancel, but okay, cancel. What is the Leibniz rule? Replace t by x. So root over 3 minus sine square x into x dash. Minus, what about the lower limit, Amma? Lower limit is constant. Constant derivative is 0. Directly you can write 0. So the lower limit, it may be 0, it may be constant. You can write directly 0. Okay, this I applied the limit. Next, here, cos y, upper limit. Same, I want to replace upper limit. Cos y, what is the y dash? Y dash nothing but what? Differentiate with respect to x. Y dash shall I write dy by dx? You may write y dash in the sense, here we differentiating with respect to x. So y becomes a dy by dx. Then what about the lower limit? 0. 0 derivative is 0 is equal to 0. Right, so derivative of 0 is 0. That's it. We got the answer directly. So x derivative is 1. So this value can take it right side. So cos y dy by dx is equal to minus of root over 3 minus sine square x. Now dy by dx, you can cross multiply this cos y. So the answer is minus of, yeah, second option is correct. Minus of root over, only one step, apply the Leibniz rule. That's it. By when I take cos y, cos y. That's all.
Sir, which option, sir?
Second option.
Sir, second option into 3.
The third option, 3 becomes here actually.
Okay, sir. Okay.
Okay, no problem. So I'll switch on the light just a minute. Got it. So now coming to the question number 44. See, they're asking this value. This value, see, 0 to 1, e power t dt value by t plus 1 already we know. This value we can change it to in this form. The value we can change it to in that form. So how can you change that? It's easy. Take b minus 1 to b, e power minus t into dt by t minus b by minus 1. Okay, students, see, for the sake of our convenience, my convenience, I'm taking in place of tx. We may change variable. We may change like integral a to b. Limits you should not change. Is equal to integral a to b f of t dt. Got it? Limits you should not change the limits. You may change like so. Now see here minus t is here, but here plus t
Sir,
is here. Yeah,
sir, does dt become dx, sir?
yeah, dx. Sorry, dx.
Okay, sir.
Yeah, see here minus t minus x minus t, but here given value plus t. Here only t, but here t minus b is there. T minus b. So what shall we do here? So here simple. This x minus b, t minus, we can consider as minus t. Here t plus 1. Okay. So this x minus b minus 1 is equal to, I want to take as t plus 1. Got it? T plus 1. Denominator is t. This total value I am considered as t plus 1. Differentiate here. Dx is equal to dt. Dx is equal to dt. Here minus x is there. Minus x. What is the minus x value? Minus x value. So just take b and everything right side. X is equal to t plus b plus 2. Got it, students? T plus b plus 2. Minus x value is minus t minus b minus 2. Got it? Okay. So once again, this and total value I am consider as t. When I consider dx is equal to dt, okay. So minus x is equal to, okay, we'll do other way. This is absolutely
Instead
right.
of substituting t as x, we can substitute as b or b, sir.
We'll do one thing. So this is the one way. In again, easiest way is we'll do in 2-3 ways. We can easily change, no doubt in that. So look at here. I want to take this x minus b is equal to minus t. X minus b alone, I'm taking as minus t. Dx is equal to minus dt. Got it? And minus x is there. Minus x is there. So take x right side from this. From this shall I take a right side? So t minus b is equal to minus x. T minus b. Take minus t left side plus t. X right side minus x. Okay, now replace. What about the limits when? Limits. Change the limits here. When lower limit x is equal to b minus 1, what is the t limits then? T. X is equal to b minus 1. Pb get cancelled. Minus 1. And when x is equal to b, what about t value? Okay, here minus t is equal to minus 1, t is equal to plus 1.
The sum alone, can you repeat once more, sir? Can you do it in the fresh page, sir?
Yeah. Okay. Tell me question.
Integration of
Integration of
e power 1 dt by t plus 1,
e power
1 dt.
1 dt. Yeah. E power
Yes, sir.
t dt.
Oh, sorry, sir. E power t dt.
Okay, e power t dt by
T plus 1 is equal to a.
is equal to a. Then evaluate the value of integral.
E power minus 1 dt by
Okay, e power minus t.
yes, sir.
No
By
problem, no problem. By t minus
minus
b
t minus 1.
minus 1. From limits, where to where?
B to b minus 1.
No, you can call as b minus 1 to b. Lower limit or upper limit, we can say like that.
Okay.
Okay, right. See here, now I am going to evaluate that the second value. Carefully you can observe. Let us take this as equation 1. I am going to take this t minus b is equal to some other variable like x minus x. Directly I am taking. Then which implies x is equal to b minus t. B minus t. Got it? No, not b minus t. Take this x, x minus b is equal to minus t. When you differentiate this, dt is equal to minus dx. Got it? Is it clear, everyone?
Yes, sir.
Okay. Now, I'm going to find the limits. These are the t limits. We have to find x limits. When t is equal to b minus 1, which implies what is the x limits? T is equal to b minus 1. Substitute here. X is equal to, that is minus x is equal to b minus 1 minus b. B get cancelled. Minus x is equal to minus 1 means x is equal to 1. This is lower limit. When t is equal to upper limit is b, which implies, substitute here. Here you can substitute. Then b minus p is equal to minus x, so which implies x is equal to 0. Got it straight? So lower limit is 0. Sorry, lower limit is 1, upper limit is 0. Substitute these values in the given equation 1. Then equation 1 becomes here, equation 1, substitute the limits here, 1 to 0. 1 to 0. What is e power minus t? E power minus t value is what? E power, shall I write x minus b? Because minus t value is x minus b. By t minus b value is minus x minus 1. This is minus x minus 1. Into this is, the value is minus dx. Dt value is minus dx. I substituted all the values. Okay, here integral 1 to 0 minus I am taking minus dx is there, minus I am taking outside. E power x minus b can be written as e power x into e power minus b by, I want to take minus common in denominator, x plus 1 into dx. Got it? See here the thing is minus into minus plus. So I want to interchange the limits. Here 1 to 0 is there, 1 to 0 is there, but in the question to take small a, 0 to 1 is there. When you interchange the limits of 1 to 0 as 0 to 1, you should keep minus. Okay. Then e power minus b. What about e power minus b? Constant. You can take it outside. You can take it outside. Okay, we can take the outside. When I take it is outside, minus e to the power of minus b. Then remaining is e power x by x plus 1 into dx. What about this value, Amma? This total value becomes what? From the
A.
given condition. That's all. That is A. So this is equal to minus e to the power of minus b into A. The answer is minus A. Second option, am I right? I think so, second option only. How logically we need to do this? This value, we need to find the integral value. I'm taking t minus b alone minus x. That idea you should get. Everything is clear then. So t minus b is equal to minus x means then dx is easy, finding dt is easy, finding the corresponding limits is easy, substituting is easy, simplifying is easy. But the first step, whatever we are substituting, that consider that value is very important. Why should we consider minus x? Why can't we substitute plus x? Because when you take plus x, you know, here t plus 1 is there. If you take plus x means x minus 1, we never get in this form that time. If both will be minus means minus you can take outside like that.
Sir, can you explain the last one, sir?
Which one? Where?
The next one, sir. Yes, sir.
Here?
Yes, sir.
Okay. So here, I think so minus, this minus I'm taking outside.
Also, the next step, sir, from that step to the next step, sir. Yes, sir.
Yeah, this one. So here, when I interchange the limits, here 1 to 0 is there. So 0 to 1 I want to write by taking minus outside. E power
Okay.
minus b is a constant take it outside. Remaining value e power x by x plus 1. So this condition already they have given this value as a. Okay, you may write in terms of t also, like 0 to 1 shall I write this value as like e power t by t plus 1 into dt. Yes, we can write. When limits are same, we may change the variable also. So this is e power minus. What about this value according to the given condition? They have given clearly it is a. Small a.
Okay, sir.
I substituted this small a value. That's all. Yeah, coming to question number 45 at first, this is inequalities. So I think 3 to 4 questions are there, inequalities, all are easy. This inequalities concept is easy. For example, here I is greater than 1, I is lesser than 1. So how to evaluate these values? So simple students, here what according to the interval, see lower limit, upper limit, that is called a interval. So what is the interval they have given indirectly? Question number 45. Integral 0 to 1. Root over. Is there any standard formula for this? No formula. X cube. There is a formula for x square, but there is no formula for x cube. So that, and also option, when you observe the option lesser than greater than is there. So here x belongs to like 0 comma 1, nothing but 0 lesser than x lesser than 1. Okay, now we can cubing. When you cubing on both sides, 1 cube. When I adding 1 lesser than 1 plus x cube lesser than 1 plus 1. So when I take a square root, so 1 lesser than root over 1 plus x cube is lesser than root 2. Got it? Root 2. When I integrate, when I integral. So from where to where? 0 to 1, here 0 to 1. See, according to the given value, I make them to 0 to 1, here also 0 to 1, here 0 to 1. So this given integral I am taking as I. Given integral you may take I also. I like that. So what is the integral 1 into dx? Here x from where to where? 0 to 1. Lesser than. Shall I write this is 1 I lesser than. This is root 2 times of x from 0 to 1. So then what about this value left side upper limit minus lower limit is 1 lesser than I lesser than root 2. So according to this you may write root 2 is greater than I is greater than 1. Which of the following option is correct, students? There is no root 2. There is no root 2. So these two are wrong. Either first option is correct or fourth option is correct. Which is correct? I is here greater than 1. When I take these two is I is greater than 1. So option 1 is correct. Once again, according to the interval 0 lesser than x lesser than 1, I'm cubing on both sides. I'm changed to integrand form. Integrand form. So finally, I'm taking the same limits. So least value is 1, highest value is root 2. So maximum value is root 2, minimum value is 1. That's it. Here coming to this, here x is lesser than 1 plus x square. Got it? 1 plus x square, here x. X, here 1 plus x square. X always lesser than 1 plus x square. Then, okay, it's better to, you can take x square. When you take x square only, now x square lesser than 1 plus x square always. And when I take a square root, here square root of x square is modulus x is lesser than root of 1 plus x square. Got it, students? Got it? Right. But reciprocal, 1 by modulus x is greater than 1 by root over 1 plus x square. So, which is correct then? Which of the option is correct? Simple, after taking it, take integral, same limits, 0 to 1, 0 to 1. Which is correct, students? This is, like already this value they have given, this is I1 greater than I2. Got it? Third option.
Yes, sir.
It's a simple question, right? And same in the same way here also, like 0 to 1, 0 to 1, 1 to 2, 0 to 1. Okay, 0 to 1. 0 less than x lesser than 1. Fine. But okay, 0 to 1 x square. In this question, simple students, but very logical. It is not like x lesser than 0 to 1 is there. 0 lesser than x lesser than 1. Got it? 0 lesser than x square is lesser than 1 square. Okay. 0 lesser than x cube is lesser than 1 cube is okay. But here, compared to x square and x cube, which is highest value, which is least value? Is here x square is highest value, x cube highest value from 0 to 1? Anyone? 0 to 1.
But
Huh?
x square is greater than x cube.
X square greater than x cube. Wonderful. Because when I take x is equal to 1 by 2, 1 by 2 is clearly lies between 0 to 1. X square is 1 by 4, but x cube is 1 by 8. 1 by 4 is greater than 1 by 8. So that x square is greater than x cube. But here 2 to the power is there. When I take basis 2, no problem. Like the symbol cannot be changed. So 2 to the power of x square is greater than 2 power x cube. First x square is greater than x cube, then 2 power x square is greater than 2 power x cube. Now take integral, also value cannot be changed. Whatever this value is, please student, integral 0 to 1, 2 to the power of x square is the value of I1, this is the value of I2. So I1 is greater than I2, got it? No need to compare any other values. First I am comparing two values. So in single correct choice answer question, one of the option is correct, no need to check remaining options. If it is a multiple correct choice questions, you must be checked. First option is right. First, x square is greater than x cube, 2 for x cube, x square is greater than 2 for x cube. Integral apply means the sign cannot be changed, like inequality cannot be changed. That is the
Sir,
right.
it is only applicable when x is lesser than 1 and greater than 0, sir.
Exactly, exactly.
Okay, sir.
It is more than 1, it's not applicable. Lesser than 1 means lesser than means when x is lesser than 0, x is lesser than 0, always x square is greater than x cube. Because cubic function always negative. X square always positive. Positive value always greater than to negative value. Okay, that is different case. As you asked between 0 to 1 only, it is possible. More than 1, it is reverse.
Okay, sir.
Okay, this we can try students. Actually, I think so. We are going to get this is I1 is greater than I3 is greater than I2 will get. This we can try students. Okay. Actually, sine x is lesser than x. Can I take like this? A sine x is lesser than x. The given interval 0 to pi by 2. What is pi by 2 value? Pi by 2 value. Pi value 3.14.
1.57.
1.57. See, sin x maximum value is what? 1. X value is what? Upper limit. Maximum value. 1.57. So, 1 is lesser than 1.57, so that sin x is lesser than to x. Sin x lesser than to x. Replace x by cos x. Sin of cos x is lesser than cos x. Replace this x by cos x. The sign cannot be changed. So whenever I apply the limit, so whatever this is I3, this is I2. Got it? Once again, the limits are they given 0 to pi by 2. In that interval, pi by 2 is x value. X value from 0 to pi by 2. Pi by 2 is 1.57. Sin x is lesser than x. So I'm taking replacing x by cos x. Cos x value also maximum 0 to 1. So cos x is lesser than sin of cos x lesser than to cos x. When I apply here I3, this I3, I2 is lesser than I3. Okay, nothing but I3 is greater than I2. I3 is greater than I2, I3 is greater than I2 is there. But now, so two options are there here, which is I3 is greater than I2. Okay, two options are there. So then what about the another condition? I want to check these two values. See, sin x, same sin x condition I want to take. Sin x is lesser than x. What about cos of sin x is cos? I'm here inside cos I'm taking, the sign cannot be changed. What about cos function from in first quadrant? 0 to 90 means first quadrant. What about cos in first quadrant? Increasing or decreasing? Graph
Sir, decreasing.
decreasing, so that sign is changing. When you apply the cos in first quadrant, it is decreasing, so that like when I take integral, this is I3, this is I1. I1 is greater than I3. I1 is greater than I3. I3 is greater than I2. Already we got it. Clear? It's a simple. Question number 49, you only do, I'll tell you this, just evaluate this value by with help of UV rule. All of you find this twin, this is u into 1 you can take, 1 is v. 1 minus x to the power of 50 all to the power of 101 you can take as u. This 1 as v you can evaluate, you are going to get this. Surely, because u dash, you can evaluate a simple, it is a simple, I think option 4 we are going to get. I'm going to explain you 50. I'll explain difficult one, easy one, you can do it. Yeah, here see again t, but limits are here. Leibniz rule. Leibniz rule. Okay, Leibniz rule here. Can you tell me what is f dash? Now, what is the pressure? F dash of x is equal to replace t by, what is replace t by? X. X
X.
into e power x minus 1, x minus 1, x minus 2 the whole cube, x minus 3 the whole power 5. But what is the value they are asking? F dash of 1. Now replace x by 1, that's all. 1 into, yeah, 1 minus 1. What is the 1 minus 1 value?
0.
0. The answer is 0. If you don't have x minus 1, okay, it may not be 0, but x minus 1 is there. 1 minus 1, 0. 1 minus 1 is 0. Clear? Right. So question number 51. In the question number 51, I am going to, this is how to do this question. I already explained. Tan x by 2 is equal to t. Tan x by 2 is equal to t. That procedure I can explain you. Instead of that, okay, let us do some other way. Like your cos x is there, cos x. What is the maximum and minimum value of cos x?
So plus 1 and minus 1.
Minus 1. When I multiply with 4, because 4 cos x is there here. 4 cos x lesser than 4. But plus 5 is there. Adding 5. 5 minus 4 lesser than 5 plus 4 cos x lesser than 5 plus 4. And the reciprocal is there. 1 by 5 plus. When I write 1 by 1 here, greater than, lesser than or equal to becomes greater than 1 by this value means 5 plus 4 cos x is greater than 1 by 9. Okay, so like now you can take the integral, like integral you can take integral from where to where, 0 to 2 pi, here also 0 to 2 pi into dx, here also 0 to 2 pi dx. You will get the directly answer. Got it? You'll get the answer. You can evaluate this value. Minimum value you'll get. Minimum value is what? X from 0 to 2 pi. Nothing but 2 pi. Okay, maximum value, not minimum, greater than or equal to is there. So maximum value is 2 pi. Then minimum value you may get this value. 1 by 9 means 1 by 9 into 2 pi by 9. Clear to it? Got it?
Yes, sir.
A simple question. And coming to your 1 plus x, 1 plus x cube. So 1 plus x cube. Here, same. We have to take 0 to 1, x cube value and x value. 1 plus x and 1 plus x cube relation. You can find those relations and you can verify that. So you are going to get the answer here. This we can try, students, this 52. Because we have less time, I'm going to explain this limit of a sum, very important and very easily. You can finish it within 15 minutes. Okay. So here you can do it this, you are going to get the answer is root 15 by 8. You can try that. So here just 3 to 4 problems are there. Once you can understood one of the formula, limit of a sum. I'll tell you the formula, remember that, very, very important. Limit, okay, first ending
So is it deleted NCRT portion, sir?
Exactly. Deleted NCRT. Limit n tends to infinity 1 by n summation 1 to n into f of r by n. Okay. R by n is equal to integral 0 to 1 f of x dx. This is the formula. What is the formula here? This you have to remember. limit n tends to infinity, limit of a sum, limit as well as summation is there. Limit of a sum can be written as like this: integral 0 to 1 f of x dx is given. So here always they given limit n tends to infinity, limit n tends to infinity. All the question you can see that limit n tends to infinity, limit n tends to infinity. Is it easy to evaluate all these values? No. So we can change with the help of limit of a sum, we can change it to standard form. Yeah, what is the first question? Limit n tends to infinity. I'll tell you. Uh, the first question is question number 53. Limit n tends to infinity 1 by n square secant square 1 by n square plus 2 by n square secant square 2 by 4 by n square plus so on. The last value is 1 by n secant square 1. Fine. Look at here, students. See, this is very easy to write. We have to write the nth term, limit n tends to infinity. Okay, here 1 by n square, fine. Secant square of 1, shall I write 1 by 1 square by n square? Okay, 2 by n square. Secant square of 4 can be written as, shall I write 2 square by n square? So on, the nth term is, the last term is 1 by n. 1 by n, shall I write n square by, sorry, not n square, n by n square. Here 1 by n, shall I write n by n square? A secant square of, shall I write 1 as n square by n square? Then only you will get idea. See here, 1 I have written n square by n square. Okay, I want to write in some form, limit n tends to infinity, summation r is equal to 1 to r is equal to n. What shall we write here? See, first, the first thing is, first point is here 1, 2, 3, 4, so on n. Shall I write here this value as n square? It is n square, n square, n square. N square is fixed. So okay, here n square is fixed. Only numerator is changing. Here it is 1, 2, 3, so on. Shall I write r? When r is equal to 1, 1 by n square. R is equal to 2, 2 by n square. Okay, fine. Secant square also fixed. Secant square is fixed by, here in the bracket also n square, n square, n square, fixed. Whatever it is fixed, you can write as in terms of n. Whatever it is changing, you can write in terms of r square. Once again, numerator is here 1, 2. Numerator alone here changing 1, 2, 3, so on. Some here n by n square, n. So that in place of the changing value, I am taking as r. But here, inside the bracket, here n square is fixed denominator, n square is fixed, but numerator is changing. 1 can be written as 1 square, 4 can be written as 2 square, here n square. So that I have written r square. See, student, whenever you can apply the limit of a sum formula, you have to check very carefully. 1 by n must be separately. 1 by n must be separately. Without 1 by n nothing but what? Dx actually. 1 by n nothing but dx. R by n nothing but x. The r by n is equal to, you can replace x. 1 by n you can replace as dx. Okay, dx. So this summation limit, you can take this here, limit n tends to infinity summation r is equal to 1 to n. This value you can take as integral 0 to 1. That's all. Got it, students? Got it? Okay. Now, is there any 1 by n? 1 by n is there? No. So you should write first 1 by n. Shall I write here limit n tends to infinity?
Sir, we
Ah,
have 1 by n square, no sir. We can take
ah,
1 by n from there, no sir.
yes, exactly. From there only, I'm going to take it is outside r is equal to 1 to n. Now, what is the remaining value? R by n. Secant square here, r by
Sir,
n.
2 r is equal to 2 we can take now, sir, because 1 by n we have taken out.
1 by n.
Sir, sorry, sir, nothing.
Okay, and one more point. A summation is belongs to R variable R. You should not take R terms outside. It is not related to N. It is related to R. So you should take N is outside, no problem. Now when we comparing this with the formula, summation is there, 1 by N is there, R by N is there. I told you very clearly, replace R by N by X. R by n by x, 1 by n by dx, remaining value integral 0 to 1. So this can be written as integral 0 to 1. R by n is x, secant square, R by n again x square into remaining is dx. That's all. Any doubts, students? R by n I replace it with x. X. Secant square as it is. 1 by n becomes dx. This remaining, this value becomes integral. Got it? Finally, we got. It is very easy to simplify. This x square is there. Now, let us take here x square is equal to t. 2x dx is equal to dt. Okay, x dx is equal to dt by 2 because x dx is there here. X dx becomes dt. So limits, coming to the limits, when x is equal to 0, t also 0. X is equal to 1, t also 1. Upper limit, lower limit cannot be changed. So integral I is equal to like 0 to 1 only. Secant square t, here x dx becomes dt by 2.
Sir, how upper limit to lower limit 0 to 1, sir?
Yeah, substitute here. These are the x
Sir, not
limits.
that one, sir. Sir, first one, sir. X is equal to 1, x is equal to 0.
Right. This is according to formula. Formula what I have written? 0 to 1.
Okay, sir.
0 to 1 only you have to take. Other than that, don't take any other values. Okay, right. So now I is equal to secant square direct standard form. That is tan x. Integral secant square is tan x is 0 to 1. By 2, 1 by 2, 1 by 2. See, by 2 is that you can take it outside. So 1 by 2 tan 1 minus tan 0. 1 by 2 tan 1 is tan 1. I think so, no option. Yeah. Fourth option. Got it, students? Once again, this limit of a sum problems are important and very easy. You can write as a summation. Summation. To write the summation, I have written 1 by n square, 2 by n square, 3 by n square, that is r by n square. Secant square, 1 by n square, 4 by n square by n square is r by n whole square. So replace r by n as x, 1 by n as dx, remaining value is 0 to 1, integral 0 to 1. That's all. So here x square I am consider as t, 2x dx is equal to dt, x dx is equal to dt by 2. Then substitute all the values, simplify, we'll get the answer.
So for smaller angles, we have that tan theta is equal to theta, no sir. So we can write 1 by 2 tan 1 as 1 by 2, no sir. For smaller angles.
Yeah, very smaller angle. If they give approximately value, that is approximately 1 by 2. But here, whenever you write equal, you should write tan 1 only. When you write here 1 by 2, bracket, you can write approximately.
Okay, sir.
Like that. They do not ask any approximate value, so that we will write just 1 by 2 tan 1. Yeah, this is C, limit of a sum. When you see, these are quite interesting questions because, we can change it to standard form. That we have to do logically. See, this question, actually, these are the previous year questions also. They do not mention here 2017, 18, 19 like that, but these are the questions of previous year. Like you can once check it, they'll give like your limit. Okay, sorry, again gone. Oh, so okay, it's luckily we got the notes. I'm planning to share the notes. Yeah, what is the second one more? In limit of sum 54, 54 limit n tends to infinity, n factorial all to the power of 1 by n by n is equal to. See, here 1 by n we required. What is the formula here? Formula you have to remember. Limit n tends to infinity already given. We required 1 by n. We required summation. Summation r is equal to 1 to n. We required here f of r by n is equal to 0 to 1 f of x dx. This is the formula. You have to remember the formula. I am going to change in this form. So limit, let us take this is equal to some y. So y is equal to like limit n tends to infinity. Shall I write this value n as n power n whole power 1 by n? Shall I write? Then shall I write n factorial by n power n whole to the power of 1 by n? N I have written n power n whole to the power of 1 by n. 1 by n is common for like numerator denominator. Whole to the power of 1 by I have written. Now I am going to apply logarithm. Log y is equal to right side also n tends to infinity log n factorial by n power n whole to the power of 1 by n. It is same as log a power m. So limit n tends to infinity 1 by n log n factorial by n power n. Okay, we got 1 by n. Got it? 1 by n. Here also 1 by n. But we require summation. Summation. Then where is summation? There is no any summation. How can you get the summation here? Yes, students? Log y is equal to limit n tends to infinity 1 by n. Okay, shall I write like this? What is n factorial? N factorial value. Shall I write 1 into 2 into 3 into 4 into so on? So on n. Clear? N power, yeah, n power n. N power n nothing but what? N is repeated how many times?
Times.
N times. Shall I write here? N times means n so on, n by n. Shall I write? Yes.
Yes, sir.
Yeah, so this is limit n tends to infinity 1 by n log. Yeah, student, what is log AB formula? Log A plus log B. Log ABC, log A plus log B plus log C. Then in the same way, that formula is for n terms. Shall I write here? Log 1 by n plus log 2 by n plus log 3 by n plus log n by n. Shall I write? I applied log A, B, C, D like that formula. Log of this. So now, can I write summation now? Now we can write summation. 1 by n. Shall I write summation r is equal to 1 to n? Okay, what is the value you are changing? Log is okay, log is there, fix it. And denominator also fix n, everything n. But numerator alone change 1, 2, 3, so on. Whatever it is changing, r. Got it? Right now this is equal to, yeah, same, it satisfies the formula. It satisfies the formula. So now I'm going to write integral 0 to 1 by n as dx, and log as it is r by n as x. R by n is x. I said very clearly r by n you can replace it by x, 1 by n you can replace it by dx, and limit n tends to infinity summation you can replace it by integral 0 to 1. Got it? So see now integral log x. What is integral log x? X log x minus 1. Okay, even if you don't know, u will do into dx. If you don't know, you can do. This is u, this is v. Yeah, u integral v integral u dash log x dash integral 1 dx. So log x into here integral 1 is x from where to where 0 to 1 minus here 1 by x integral x into dx x get cancelled. So here for upper limit log 1 value is what, student? 0 minus lower limit x in place of x substitute 0. For upper limit it is 0, log 1 is 0. For lower limit x value is there, 0 into log 0. Okay, anyhow 0. This is x from where to where 0 to 1. So that is nothing but minus of 1 minus 0. Finally the answer is minus 1. Okay, after doing all these steps we got answer is minus 1. Oh, sorry. Okay, here it is 1. But this is left side is what, students? Left side is log y. But we required only the value of y, not log y. When I take here e get cancelled. Y is equal to 1 by e. Any option 1 by second option. Got it. Log y value is minus 1, but we required only y. So take here base is e. So that both will be cancelled. So e to the power of minus 1 is 1 by e. Got it? Changing to this form is important. After changing integral, okay, evaluating integral, no doubt, that is easy only. How to change the standard form, important. So remaining also I'll change just the standard form. Integral and all you have to do it. Sn you can write in standard form. Okay, 1 by 1 plus root n, 1 by 2 plus 2 root n square. So how to change students here? Yes, 1 by 1 plus root n. See, what is the value you are changing? 1, 2, this value is changing. Root n is okay. Question is, what is Sn, students? Sn is equal to 1 by 1 plus root n plus 1 by 2 plus root 2 into root n plus 1 by n plus n square, root n square. Shall I write root n square as root n into root n? When you observe that, what are the values are changing here? Anyone? Here 1, sorry. The values are changing here. 1, this value. Okay. Then any other value is changing here? Yes, other value also changing. What is the other value is changing? Like, this one can be written as actually root 2, root 3, root 4, root n. Root 1 will write. Shall I write here this value as root 1? Root 1, root 2, root 3, so on, root n. So Sn can be written as summation 1 by r is equal to 1 to n, 1 by r plus root r into root n. Shall I write like this? Root r into root n. But in the question they given limit n tends to infinity. Here also limit n tends to infinity. But there is no 1 by n. Without 1 by n, 1 by n is must in the formula. Is there any 1 by n? No. So that what shall we do? Multiply and dividing with n. So limit n tends to infinity, 1 by n, you can take it outside, this 1 by n. Here this n, you may write here this n is here, or else n maybe you can write here, no problem. Summation r is equal to 1 to n, 1 by, shall I write separately r by n, Here, shall I write square root of r by n? Students, shall I write square root of r by n?
Yes, sir.
Yes. Now you can write simply 1 by n becomes this limited summation becomes integral 0 to 1. 1 by n becomes dx. R by n becomes x 1 by x plus root x. This value you have to evaluate. So to do this, how to do again, you may get doubts, sir, how to do this. Yes, root x you can take common, root x plus 1. Got it? This root x plus 1 is equal to, you can take as t. You'll get answer very easily. Got it? Changing into integral is very, very important. What are the values it is changing that you can take as r, whatever it is constant, like you can keep as it is. Fine. This evaluate these values, so it's no problem. Finally, last question, 4n square. Final question. What is the question? Question number 56. I is equal to integral of, not integral, sorry, limit n tends to infinity. Here also, what are the values are changing? 1, 4, 9, so on. 4n square is fixed. 4n square, you should not change anything. 4n square is fixed alone. Only 1, 4, 9. This is very easy to write. Limit n tends to infinity, bracket 1 by root over 4n square minus 1. 1 can be written as 1 square plus 1 by 4n square minus 4 they have given. That 4 I want to write as 2 square. As 1 by root over 4n square minus 3 square. So on. 1 by, shall I write here? Observations. 3n square. This square root of 3n square, shall I write 4n square minus n square? Now, limit n tends to infinity. Summation r is equal to 1 to n. Anyone can say that what shall we write here? Root over. See, 4n square is fixed. 4n square is not changing. 4n square, 4n square, 4n square. Here also 4n square. Only second value is changing. Here 1 square, 2 square. That is, you can write as r square. Shall I write that value as r square? This we got. But again, the question is that is there any, see, we required 1 by n. Where is 1 by n?
So we can take n common, sir.
N
N
square is
square in the denominator.
exactly, wonderful. So limit n tends to infinity, summation r is equal to 1 to n. Take n square outside, it can be written as 1 by root over 4 minus r square by n square, r by n whole square. Got it? 1 by n is there, r by n is there, replace r by n by x, 1 by n by dx. So this is can be written as 0 to 1, 1 by square root of 4 minus x square into dx. This is nothing but what, students? Sine inverse x by 2 from where to where? 0 to 1. That's all. This is in standard formula. See, 4 can be written as 2 square, a square minus x square, sine inverse x by a. Apply the upper limit and lower limit, then you will get the answer. Sine inverse 1 by 2 is 30, 30 minus 0, 30 is the answer, 30, first option. Having any doubts, students?
No, sir.
So last question, one minute, when you show the answer.
Yeah, okay. Yeah.
I told you that we have the doubt in the OBT paper, no, sir. One question.
Oh, yeah, you told one question. What is that question? I forgot actually.
1 minute, sir. I'll open the papers.
Yeah.